and the floor is yours, DJ.
Thank you very much. Yeah, it's very exciting to be here. It was actually my first involvement with Amplify Louisville, so that's super exciting. I guess I have a couple questions first. I'm gonna I have a slide deck that has a handful of slides in it, but one problem I have is when I present it, I lose all of the other display of my screen, so I can't see anybody's pictures or see the comments. So if I share my screen and just don't present it, I guess the question is, can you see it and does it look all right? So I'm sharing it now.
Yeah, that's fine. I can also read the questions out to you if you prefer.
Okay, perfect. Well, this way it kind of give me a little bit. I have a couple other things around me, so I'll just leave it at this for now. I don't. There's no animations or anything like that, so I think it'll be fine. So okay, let's get started. So this is the product that we're going to talk about is called Falling Saber, and the whole talk is around the idea of teaching. Originally, we said roadmap, and I've since changed it. I didn't ask Mike if I was allowed to change it, but I just did it on my own and figured once I was here, he couldn't really stop me anyway. So I changed it to being teaching a concept roadmap because most of the work that we're doing with this one is we haven't made it to the real final product yet. So it's really how did we work with this partner and how did we help them build a concept that would allow them to go to that next phase? How would they take what we built and use that as the kind of the catapult to build the real end product? So the picture here, I wanted to kind of give you a minute to look at this, but Falling Saber is basically a product that imagine that you have a cargo carrier. This is a military application, and you're going to throw a bunch of boxes or pallets out the back of the plane with parachutes, and you can see here there's a lot of them. And then they're going to go scattering all over the earth and you're going to have to go find them all. And so it seems like when you first think about, oh, I'm going to throw a 8 foot by 8 foot pallet out of a plane, that should be pretty easy to find. But surprisingly, in a jungle, an 8 foot by 8 foot pallet is really hard to find, and you don't see very far. So what Falling Saber was a concept product that we helped them build that allowed them to track those kind of assets when they're being deployed out of a plane in that situation. So kind of go through the slides here, but we're going to talk about a concept roadmap. So this is basically going to be a story of how we worked with Data Anchor to solve that problem. So a couple housekeeping things out of the way. Ignore the picture. You might see me on the street. You either talk to me or run, whatever your choice there. As Mike said earlier, I'm the co-founder and CTO of August 20. We're a fairly newly created consulting company in Columbus, Ohio, but we love working wherever. And now with the remote capabilities of most companies, we'd love to be involved in anything in Louisville or even wherever people are located. There's a couple pieces of information there. If you got a question later and you want to send me an email, that's our website. Check that out. And if you're really interested and want to see us on Instagram or Twitter, there's our handle as well. So the agenda today, and it doesn't have to be super rigid, but the idea is I'm going to kind of give you a little bit of background on Data Anchor and how we kind of got involved with them, problem definition of what we tried to solve, requirements discovery, how our process kind of worked us through that, how we delivered the MVP, and then how we were able to move fast. And as Mike said earlier, I don't have any issue. If you've got a question, just yell it out now. Or I guess, Mike, you can yell it out if they type it in, but we'll just make this a conversation all the way through. So this talk is about this partnership that we formed with Data Anchor. They've since changed their name to the Anchor. They are a data encryption platform. They're also out of Columbus, Ohio. They do a lot of work with banking industry, anything that involves data on the wire or data in flight, and that needs to have a fairly high security kind of, let's say, security setting to it. Data Anchor takes a unique concept that the data is live all the time, but you can change the permissions on the fly. So for example, I could send some kind of a document to someone. I give them a certain set of permissions. Maybe they're allowed to view it. They're not allowed to print it. They're not allowed to modify it. But then an hour later, I realized, oh, that was a violation. I can retract their permissions instantly. Whereas most of the world, we send PDFs or we send documents in email, and once they're sent, we've lost them. So that's kind of their aspect of what they work on. This project, they were applying that encryption to the data that's coming from these devices that would be in the military scenario. And I've kind of already introduced August 20. So let's just get right into the middle of it. So the problem that we were solving with Anchor was that they needed, and this was their problem statement. So this is where we started. So how do we get from an idea, the problem statement, to this concept roadmap that we inevitably delivered at the end? But they were trying to build a GPS-enabled communication beacon, delivering real-time encrypted positioning data for airdropped assets from aerial deployment to ground recovery. So what that means is, think of once again, we have this pallet of supplies they're going to throw out of a plane. That's their asset. They're going to drop that out of a plane. They want to be able to track it from the moment it leaves the plane until the moment they recover it on the ground. They want to be able to do things like, is it falling? Is it on its side? Is it upside down? Based on the GPS data, they can tell, did it land in the middle of a river? How do I have to acquire, this piece of asset when I go to find it? The real key to this was it needed to be small, lightweight, rugged, and reusable. So in this case, you can imagine a military application. They're not being super kind to the hardware. They're not, iPads laying on a desk and people using, kid fingers to use them. They're beating these things up, so they had to be fairly rugged. So the requirements that were put in front of us with it: real-time data, real-time location data, pinpoint accuracy. And I laugh when we say pinpoint, we're talking like 30 to 40 feet, but we're not talking millimeter accuracy here. But when you're trying to find an 8-foot by 8-foot pallet, 30 or 40 feet is pretty good. You can find a pallet usually within that distance. 100% situational awareness. So as this device falls out of the plane, we actually have a mobile app that was built that would allow us to track all of the statistics of that device. And so we know, is it landing in a hostile environment? Is it landing, as I mentioned earlier, is it landing in a river? Has it landed on top of a tree? Those kind of things. And then actionable information for the recovery force. So now that they know where it's at on the ground, how do they go get it? What tools or what supplies do they need to be able to acquire that? Zero asset loss and long-range encrypted transmission. And that's the one we're really going to focus on today, was the long-range. How do we send encrypted data from these devices? Remembering that, and I think, do I have my screen on? Yeah. So this is actually, if you can see this, Mike, help me out if you can't. This is actually one of the prototypes. So this is how big they are. So you can see my hand. This would have actually a zip tie mechanism to it. You would zip tie it to the netting around the pallet, and then this was what would be thrown out of the plane with the pallet. So this, it has an internal LiPo battery, so not a lot of power. So how do we transmit that data over really long distances through conditions where there are a lot of trees or obstructions? And so we'll get into that a little bit. But so that's kind of what was the problem? What were the requirements they set forth in front of us? And then this is kind of a high level of just a visual of what they were trying to do. So imagine that the device, which is the little picture with the parachute, that is the device we're going to attach to the asset that we're going to throw out of the plane. That's what they consider data at rest. So it's not moving, it's not doing anything. As we throw it out of the plane, that's data in use. So it's collecting data as it's falling. And we'll get a little bit later. It's not always a parachute. It's not always falling. They're actually finding other uses for this device. But in this case, as it's falling, it's collecting data and transmitting that data in real time. And that's when the data is encrypted. So that's data in motion. So that's when it's most vulnerable. And then the receiving unit receives that data, the base unit, and then they of course consume that, and then they're using that to view it on whatever system they're looking for. Sometimes it's used after the fact. Sometimes it's real time and used to to find the asset. So the objectives that we had were threefold. They needed to realize a concept because they didn't even know if they could build it, and they had a possibility of winning a contract that would, if they could build it, they would be able to basically win the contract and build the product, and inevitably the whole reason we're all here at some point is generate revenue for their company. So that was why we got involved, because we're in the position to be able to help them build software and help them utilize hardware to realize that concept. The side effect of that was they wanted to be able to provide access to this contract they were trying to win. And then even a further side effect of that was opening new markets. So I'll come back to that. So these three things I'll come back to in a little bit, and I'll give you a little bit more detail. Like after we walked through this process, how did they realize these objectives? Sorry. All right. So then now our process. So how did we help build this concept roadmap for this idea that they had for this customer or client, in this case, the Data Anchor? So the way we work through this process is the first thing we do is we want to build a relationship with the client. You know, we feel that if we actually, there's a saying that you always want to work with people you like. You can always learn to get things done, but if you like somebody, you'll make an effort to work with them. So we really believe that becoming a partner and building that relationship with Data Anchor was key. The second piece of that was understanding how the operator, in this case, the military personnel that would actually be using the product. So, you know, we had visions, Data Anchor had visions of how they would use this product, but when we actually met with real military personnel that would be in the back of a plane, you know, you don't think about this stuff, at least I didn't. You know, they have a parachute on because they might fall out of the plane. They're tethered to the plane because they're moving at a very high rate of speed. They've opened the back of the plane up with this giant gaping hole, and now the wind is blowing around and they're trying to get pallets thrown out of a plane. It's a pretty dangerous environment. Dealing with a little box like this is the last thing on their mind. So a lot of things that we had to understand were they wanted to be able to, like, when they pick them up, they should activate. There should be a very simple mechanism with a pre-built zip tie that they can just zip tie it to the device. When it lands, they don't have to do anything. They just rip it off the netting, throw it in the Jeep, take it back to the base, and then they just get stuck back onto the recharging. There's really no work to these things other than just having one in your hand. So understanding how that process worked was very, very key to building an end product. And then the last piece of discovery was just helping them work through how to define the concept roadmap, which is why we're all really here today. So the way we worked through this is we basically, you know, our process was determine the MVP, which we've already talked about. And in this case, it was how do we design the hardware? What choices do we make? What off-the-shelf things can we use? What things do we have to build custom? Same with software. What software do we use? What languages do we use? What development environments do we use? And then real key part of it, because it was a concept roadmap for them, we don't know whether we're going to be helping them in the future. So we had to put them in a place where there's good documentation, good code management, and good testing so that their team can pick it up and run with it if need be. Now, obviously, we're really hopeful that, you know, as a partner, we're going to get to work with them in the future. Plus, it's a really cool problem and we'd like to be part of it. But we always like to put ourselves in that place where, you know, thinking through that roadmap is not just deliver something and walk away from it. It's really how did we build something that they can use in the future and not hinder them because of our choices. So this is how we thought through the roadmap, and we do this fairly common and fairly consistent across a lot of our projects. So I'll kind of walk you through this picture, and hopefully everybody can see it. The words are not super important if you're a little bit small, but the boxes on the left, the black boxes, those are really what we've kind of labeled as themes. So what are the themes that we have to accomplish in order to get this roadmap or this product built? So in this example, it was hardware, software, dev environment, all the things that I listed on the previous slide, even down to what protocol are we going to use and what sensors are we going to use, those kind of things. And then, so those are kind of the questions. The gray boxes underneath of the now, next, and future, those are the answers to the questions. So we typically ask the question of, you know, what hardware do we need to use? And then we try to answer that of what's the quickest thing, the most cost-effective thing that we can just do to get ourselves moving. So the challenge we had with this one was there were a lot of unknowns. Their requirement of a long range but low power was very, very challenging, you know, very challenging opportunity. I'll be positive in that one. But so we actually made a decision that, you know, how do we answer all the now questions to get us a first working prototype? So the answers really aren't important in this one, but, you know, for example, we chose Raspberry Pi because we could walk to the electronics store and buy one of those off the shelf. They're fairly cheap. We used a language that was, accessible. We used things like GitHub where we can store the code, very easy to get to. We did most of our testing on a local environment to start with. And then the real key here was, so we basically said we're going to do all of those. We're going to do everything in the now, and we're going to really focus on the protocol, because we felt that that was the most critical of what they required. It was also the most challenging. So the first part of the now was, let's pick a protocol. Let's get everything else working. So we had, if you kind of walk through the scenario, you have a device, you have this device. Inside of that device are sensors that we're going to be collecting data from. We need to encrypt that data, send that data across the air, consume that data somewhere else. For the POC was, what's the simplest thing we can do from a protocol? Are we still good, Mike? I'm getting an unstable internet connect. Okay, good. So we chose Wi-Fi to start with. The longer term solution was either something like LoRa, which is a long range protocol, or a cellular, but we'll kind of talk about those in a minute. But Wi-Fi we chose Wi-Fi to begin with, because think about any device you have. Your phone has Wi-Fi, your laptop has Wi-Fi, your desktop has Wi-Fi, the Raspberry Pi has Wi-Fi. So let's make everything work over a Wi-Fi connection, and then we'll worry about moving to the others as we go. So that was kind of this picture here. When you look at what Wi-Fi can do, high bandwidth but short range, LoRa is the reverse of that, which was inevitably where we wanted to be, but we chose Wi-Fi to start. So now I'm going to give you some really, high-end graphics here. This was just a first version of, and we instead of building the final version, we said, what is the simplest thing we can do? Well, we used a particle I/O board. We used a breadboard with some jumper wires. And if you notice the little blue, I think you guys can see my mouse, the little blue box right here is not what we inevitably wanted to use for the sensor, but it does temperature and humidity. But the nice part is it actually delivered data to us. So we were able to get that working, encrypt the data, send it across the air, across Wi-Fi, and then decrypt it on the other end. And so then as we worked through that, we were able to get something up and running in a day or two. And then 2 or 3 days later, we moved to a Raspberry Pi. I'm kind of cheating on timeline here, but at some point we say, this is going to have to be a device that we throw out of a plane. We can't have a power cord. How do we do a battery power? So then that's the next step that we go to. And then inevitably we get to this part here where we actually do have a real GPS sensor wired in. We have a real sensor that does accelerometer, gyroscope, magnetometer. So now we know, are we going northeast, south, or west? We know, are we upside down or right side up? How fast are we accelerating? All of that data is being consumed and then encrypted and then sent across Wi-Fi. So the real advantage was that we actually had a working prototype in the hands of the client within 2 or 3 weeks. And so instead of 2 or 3 months, we had 2 or 3 weeks, and then they got to see how it worked. And they actually started making changes, not to necessarily the hardware, but how the encryption algorithm worked. We realized that their encryption algorithm or their SDK that we used to encrypt was too big for the Raspberry Pi. So they actually went back to work. And if they'd had to wait 2 or 3 months for that answer, we may not have met the deadline that the military put in place for them. So that was kind of version 1. So then, the last piece, sorry, there's one more. This is where we actually took the device and strapped it onto a drone that we had, a quadcopter that we had, and we just flew it around. Will it broadcast? Wi-Fi is maybe, if we're lucky, 300 feet, 400 feet at the most. We could test things like, when we fly out of range, what does the device do? Oh, it stores the data on the device until we come back in range. When we come back in range, does it start does it catch up? Does it retransmit all of the stored data back to the base unit? Those were things that we could test, in a real world situation, but still within that Wi-Fi scenario. So the next piece, we kind of had that delivery. People, the company and kind of appreciated the fact that they had something working in their hands. Obviously not where we ended up with. So now back to the roadmap. So As we showed earlier, we had the now, and then we had the next. And so the way we always look at this is the now is what are we currently doing, but it's answering the question in front of us right now. What is the next thing that we need to do? Or the current thing that we need to do. The next is what is the next smallest step that we can go to get us to that end result. So in this case, it's a little, I'm hoping you can read it, but we took the Raspberry Pi and said, well, the Raspberry Pi is a fairly big device. What if we use a Raspberry Nano? We said, that's okay, let's do that. We're going to go ahead and continue to use some of these other things like Python and GitHub. We're not going to change those out. Well, we did documentation when we started with, we got a README file, which is a flat text file. Now we're going to move to some kind of a wiki where we can actually get input and more people can see it. We're actually going to move from Wi-Fi to LoRa, which was a big step because we went from built-in Wi-Fi radios to now we have to buy hardware. We went from a humidity sensor to an actual, the one I showed, the GPS, the magnetometer. We're actually collecting the real data that we want. But most of the components were already working. So we only had to change the things that, for example, get rid of the humidity sensor, solder in a different kind of sensor. So where we ended up with that, so if you look, I'm going to kind of go back and forth for a minute. If you look at this slide, the next, Nano, GitHub Wiki, LoRa, GPS, as we move along, that now becomes the now. So that's the current version we're working on. The next becomes what is the next thing we want to work on. And then I purposely made this show that there's question marks in the future. As we go through the now, we're going to learn and things are going to change. The customer's going to have different requirements. And the future is always going to be, we're going to start thinking of the future as we're working on the now. And so this just kind of rolls along. We may never make it to the ultimate future because we may get to a point where the product is good enough that we're ready to be done, ready to deploy it. So I've highlighted in this one the LoRa, just because we talked about Wi-Fi before. At this point, we were in the roadmap to say we've made it all the way through the roadmap to we have a workable model and we're using Wi-Fi. Now, how do we get to LoRa? So LoRa gets us to that long range that they're requiring. The bandwidth was not an issue because we're just sending sensor data. So LoRa was really the perfect solution for what they were looking for. So this is a picture. Now we're getting to the next phase. It's hard to tell, but in this picture, there's actually the LoRa radio's been installed. All the sensors are still the same. The programming is still the same. We're reading the same data from the sensors. It's being encrypted in the same way, but instead of being sent across Wi-Fi, it's being sent across LoRa. So we very quickly were able to go. Now, you'll notice the white box. BattleSight was the name, the code name of the product that Data Anchor was delivering. This is us walking through, in an iterative process of how do we build a 3D printed case. You can see little lines we've drawn, and how does the battery fit in there? How do you get into it? How do you reset it? Obviously not a final product, because once again, we said this was a concept. So the last piece of this was, in the story of how we built this, we made a lot of decisions that, from a technology standpoint, from a hardware standpoint, just from how do we work as a company and how do we work with a client, that allowed us to move fast. Our belief was that if we could make the customer see a working prototype, they would then understand what they were really getting, and then we could work on how do we tweak that to get it to the end result of what they really needed. So things that made us go fast is we tried to pick, and this is back to the concept roadmap. We're always thinking about, what is the most accessible thing that we can do, and what is the most accessible language or tool or hardware that's in front of us. So for example, let's go with hardware in this picture. We started with a Particle IO board, which you can buy for $10. That got us to the next step of let's move on to the Raspberry Pi. And then we went from a Raspberry Pi, like a Model 3, to a Nano because of size limitations. And then probably inevitably where this project will end is there will be a custom board made. One thing we didn't prove on this POC was the data coming from the sensors. The moment it leaves the sensor to the moment it arrives at the SDK, it's unencrypted. Now, for the POC, that was fine. Probably in the real world, they're going to want to encrypt that data from the moment it leaves the sensor. So probably a custom board that has the SDK built right on the board, right into the firmware of the product, which Mike, you and I were talking earlier about, do we get to that level? And we do sometimes. We can actually, protect that data all the way from the moment of capture to the moment of delivery. And that goes across the board. So all the sensors, probably the sensors that we chose for the POC will not be hardened enough to be in the real world, but they were good enough that we got the POC out in a state where Data Anchor could take it to the client, in this case the military, but show them what we had. So that's kind of how we moved fast. So let's go back to those three objectives. So now that we've put this roadmap in place and we worked it iteratively, and we kind of, one of the things I think is key for us is we always look at what's now, what's next, and what's in the future. And so that we're not trying to, either gold plate or try to solve the solution that we don't really know how we're going to get there. But the way we accomplished this, we were able to realize these three things. So the concept we realized in a physical device. I have one of them in front of me. I keep holding it up. Honestly, it's kind of super cool to actually see it in person. It's not that exciting, probably over the camera, but the idea of taking this thing and helping. We always like to say our military heroes. We're actually making their jobs easier, and inevitably that is a positive for us as well. But they were actually able to see a physical device. It wasn't just a concept. It wasn't an idea in somebody's brain. They actually could take this, plug it in, and they even had scenarios where they would take it and one person would put one in a car and they would drive around the building, and the people in the building getting to see the demo would see the data change. The second piece of that was they actually were able to provide access to the contract they were trying to win, which was initially a $1.5 million contract, which got them to the next stage. And then the ultimate goal was they wanted to open up new markets. So there's a couple things about that. One, when they originally came to us with the idea, they only had a single focus of, we need a physical product that can transmit encrypted data over a very long range. And so the approach that we took by building the roadmap incrementally or iteratively was that we inevitably came out with a product that was Wi-Fi based. And then they started realizing, well, we can use this in a non-military fashion. We can use it in warehouses. We can use it on logistics companies. We can, anything that where an asset needs to be tracked, now they have an option of using that, especially when the data needs to be encrypted. So it opened up a whole new market for them that they weren't planning on even having in their back pocket. And so the last piece of that was, I actually just typed "just announced" there. So this is actually a screenshot of a LinkedIn post that Data Anchor just posted a few days ago. The work that we helped them do is part of what they're calling the Advanced Battle Management System, which is inevitably just a cool name. So that's kind of fun to be part of. But they are one of 24 vendors in this battle management system that were just awarded $950 million. So the approach that we used helped them land that. And so I think they learned a lot from us on how to do that. I think we learned a lot on how to work with companies like Data Anchor and how to build that product and how to get that in their hands, in a very fast way. So that is really, I'm supposed to be 30 minutes and I'm at 33. That's pretty good. That's really the end of what I had for slides to kind of get just some knowledge out there. And I'd really like it, just a question, what questions do you have? What do you want to know more about the project? I'd love to talk just, in whatever capacity you have.
Awesome. Thank you so much for that, DJ. That was great. It's pretty incredible to see, MVP development from start to finish. And I know my question in particular is around that roadmap. And for the roadmap, when you are thinking up the concept and here you do your now, next, future, how far into the future are you looking? I remember working for Continental Automotive when we were working on adaptive safety features back in my internship and co-op days, and we were looking at early braking assists and lane departure warnings, and this was like very early in its development, but they were looking several years out. And I'm curious, especially with how frequently technology changes, how far should you really be looking?
Well, that's a great question, and that's a tough question. I think specifically for this, I'm just going to talk about the falling saber one just for a minute. Um, we had a fairly short timeline, so we weren't thinking more than maybe 3 or 4 months out. So we were able to make fairly quick 1 or 2 week iterations on getting the product in their hands. Now that they've won the future, they've won this. They're part of this $950 million project. They're going to have to think longer term. Now, whether or not we get to be part of helping them with that, we sure hope so, but we'll see. But it does change the way you're thinking about it because our solution, we got to think about it from a retail standpoint. I mean, can we go buy a Raspberry Pi out of from Micro Center? I don't know if you guys have Micro Centers, but think of an electronics store. Um, if you're dealing with, I mean, as you mentioned earlier, and you kind of do your example you gave there, when you're building the roadmap, you're helping this client build the roadmap in let's say an automotive space. We've done a lot of work with autonomous vehicles. You you're not thinking 2 months down the road. You're thinking 2 years down the road. You're thinking maybe 10 years down the road, because once you deploy that car, sell that car, it's there. You can't. Cars are getting better with software updates, but there's still a hardware aspect to them. And so I think it really depends on like what you're building and what your inevitable goal is. Software is a lot easier to change. We can change it on a whim. We just redeploy. Now, obviously, software deployed to a piece of hardware is more challenging. A lot of cars are getting over-the-air updates now. That makes it easier. But and I think I probably haven't answered your question yet, but it really is a tough question because I think every roadmap or every idea put in front of you, that roadmap really becomes specific to the problem you're solving. And so if let's use the automotive one for a second. A lot of choices that you get to make in the automotive field, you don't specifically get to make. There is a OEM, pick whatever manufacturer you want to pick. They've probably got at least one or two levels of vendors that are bringing them products to the table. The vendors are building them very specific to the OEM's needs. And there's a lot of research, there's a lot of money invested, there's a lot of time actually manufacturing them. Use your braking system as an example. It's not like you can manufacture 10,000 of those and then deliver them to the OEM and then decide tomorrow, oh, that isn't going to work for me. I'm going to need to change that. So a lot of times, you're thinking way down the road of what features do I want to deploy to that product, and then build the solution around it. This one was a little bit more open-ended because we were really more in a POC, mentality. So I think it's a challenging question. I think that's the real idea behind what we're trying to do is what is the now, what is the next, what is the future, and that future may go. I said earlier to somebody there might be 95 next in the middle of now and future. You just don't know.
And so this really has to be a living document then. And
Absolutely.
if you're considering new tech and external forces, like maybe in the automotive industry, it was probably because it's highly regulated. There's probably regulatory timelines that need to be considered.
Yep. Yeah.
Okay, so living document.
Yep.
And how frequently do you think you are needing to address it? How frequently are you needing to discuss it? Is it only when there's an issue that comes up? Is it only when you are looking to make the next iteration, or are you constantly just
Yeah.
keeping an eye on it?
Well, so I'll answer it like I did the previous one. I'll answer it two ways. So the roadmap in front of you for Data Anchor, that was a pretty daily conversation. We'd make a decision to go. So I'll give you at least in my mind, a really good example. We decided on the second iteration to go with the Raspberry Pi Nano. It's a much less performant device than the Model 3, just all around processor performance, memory, all of that kind of thing. The SDK that they had built, that Data Anchor had built, that we would use to encrypt the data, was too big. Too much real estate was required from a memory standpoint to actually install the SDK on the Nano. So we had a conversation around, do we abandon the Nano or do you guys rewrite your SDK and only deliver us a minimal version of the SDK for proof of concept. And so we actually did that. So that's one of those times where software and hardware and the business have to be really involved, because if we would have delayed 2 or 3 days, we might not have made the cutoff of when they wanted to deliver it to the customer. I think that still applies regardless of how big the roadmap is. I think it really is. And I think one of the things that we like to, our way of working, I think, most people work this way, at least I hope they do. Software is not the software and business and in technology and all that really have to be all one thing. They're all in support of solving the problem that's in front of you. So the business is going to have to make hard decisions sometimes about, what technology we use, just from how new is it, how unstable is it, how risky is it to use it, but maybe the benefits of using it are outweigh the risks. And then just from a business standpoint, we could probably sometimes come back. Let's use your braking example again. We might actually identify that the hardware we have in place, even though it was a large number of them were manufactured, if we could get them to change the hardware, we might be able to deliver 3 more features that weren't envisioned a month ago or a year ago. And so the business will have to make those decisions of, well, do we go ahead and release with a limited number of features and then have maybe a subsequent release with a new feature or new set of features and new hardware, or do we just scrap what we're doing and go get the new hardware? The roadmap is really, we usually, I mean, we usually just say it's kind of our moment in time. You blink, it's going to change, but it at least gives you a roadmap of what are you thinking right now, and at least you're consciously making that decision of what you're going to do tomorrow, not just flying around kind of haphazardly.
And to add on, you just mentioned too how basically how important it is to understand your requirements and your
Yep.
constraints.
Yep.
Being able to understand what is compromisable or what needs to come first, understanding those requirements from the customer as well as the constraints from your suppliers and or the technology you have is super important.
Yeah. Yeah. That's a really, I think you and I were talking before we started today. We were talking about, things like automotive or agricultural or any of those kind of things. There's a lot of really stringent specifications that are mandated. NHTSA has a set of, ISO, they're part of the ISO standards that say an autonomous vehicle has to behave in this way. The military application might be less stringent. I don't know the answer to that how stringent it is, but it really depends on what you can and can't do. And you're going to make decisions based on those things. So it's a really good point.
What other questions do we have for DJ?
I think that what you're pointing out is that in order for companies to stay competitive, they need to be very agile, and especially if you think about the rate at which technology seems to be increasing. You think about life before the GPU and then life after the GPU, what that opened up in terms of artificial intelligence and natural language processing, vision systems, and things like this, that the automotive industry could, if they were nimble enough, take advantage of today. But my experience in working with major automotive manufacturers are that they, from a technology standpoint, they're just way, way behind the curve.
Mm-hmm.
And so I think that is an interesting problem to solve. And I think this helps do that because you constantly iterating on it. You're thin slicing it, and it sets, you don't get, it helps you not to get locked into what could potentially be a dead end in your future.
Yeah. Yeah. I think I figured you were going to ask questions. So Tim and I have been longtime coworkers. So I did not prompt him to ask that question. But, I do agree with you, because the thing that's interesting, I think, especially using your automotive example, a lot of the big, and I'm not an expert in any of them, but my experience in working with them over the years has been, they have built very large manufacturing companies, that were not originally designed to be technology companies. They were built to be manufacturing companies. And so now all of a sudden you start seeing companies like, I mean, think of whether you love them or hate them, Tesla has changed the way we build cars.
Absolutely.
Companies like Argo AI are formed because Ford couldn't get the autonomous vehicle platform moving fast enough because of the challenges of being inside of a big manufacturing company. You know, you see, and there's how many automotive companies are out there right now building, you know, Neos and you know, all of them are out there trying to do it. They're software companies, they're technology companies. The platform just happens to be a rolling device. You know, it's crazy the number of sensors that are coming out on vehicles. I mean, thankfully, all of that's, you know, the project that we're just talking about right now with Falling Saber is, you know, a benefactor of that. You know, the hardware that we get to use today, 10 years ago was unattainable. Just one, we couldn't get it, or it was just too expensive to acquire.
Or you couldn't power it. You know, lithium ion changed the game there.
Yeah.
And so we're probably getting off. I'm probably getting us off in the weeds, but the point being that you know, miniaturization, power, advancements in power stuff. Those are all just great examples of why it makes it harder to predict the future, right? You don't know that you're going to have those things available, and they open up an entirely new world of opportunities.
Yeah, and that's why I was kind of mentioning the timeline of how far you should look off into a roadmap. But because it's a live document, I guess there's no harm in continuing to look out into the future, because it's always going to be changing. You should always be addressing it. Jake Miller is a local entrepreneur with a hardware software device for the healthcare space. I know he's got a question.
Okay.
Yeah. Hi, DJ. I got a question about this product in particular. Feel free to not share it if you can't share the information, but you mentioned that you have a reusable component, or you designed it to be reused. I also have a similar model, and I've learned that there could be some challenges with people actually just disposing of the reusable component or not charging it appropriately so it's not ready the next time. What kind of things did you guys design into your reusability to make sure that the necessary components, tools were there when people needed them?
Yeah, that being that it hasn't been actually officially released as a product, we haven't seen how they're actually going to use this in the real world. The things that we did build in, so I don't have any pictures of it right now, but we do have, there's actually a component you can buy for the Raspberry Pi that gives it the, you know, transducive charging. You know, you lay it on the charger like you lay your Apple Watch onto the charger kind of thing. So the idea would be that these devices were built in a way that the software was smart enough to know if it's charging, just let it charge, but don't start collecting data. And then the use case was, so imagine that you're in a plane, and I've never been in a cargo plane, so I can only look at pictures that they've shown me, but you know, they're fairly minimal. They're not, you know, they're not your commercial jet. So on the wall would be a big rack of these devices, and they would all be, you know, like charging. And when they were ready to shove one of these pallets out of the plane, they would reach up and grab a hold of it. It would be in a case that had a mechanism to attach it to the asset. The moment that it would detect that it would stop charging, it would start collecting data. And then it would collect data until someone actually put it back on the charger or it ran out of batteries. The batteries that we had on there would run for about 4 hours but then they were dead after that. So their belief was that, you know, by the time you throw it out of the plane and go get it, 4 hours is, at least for now, it was fine. My belief is that it would just be a process of how to get them to reuse it. I'm envisioning there would be some lost. I can't imagine that if they're trying to recover supplies in the middle of a jungle, this device is probably the last thing on their mind. Whatever makes it back to the base, they'll collect them and put them on the chargers. But we really didn't. Our part of the project wasn't to solve that problem. We just dealt with the pieces that we thought would be helpful as far as the charging and things like that.
Jake.
Thank you. Yeah, I was kind of wondering, since you're using some cheaper microprocessors, if one of your thoughts were you're going to have a lot of loss of of these.
Yeah, and honestly, I think, and if you, I've kind of slipped past the future. I think our long term vision would be that Raspberry Pi would not be the final solution. Probably it's not hardened enough to even deal with the, all the vibrations and all that kind of stuff. This was really just to get them to that concept. I mean, it did its job. It won them a contract. Now they have to actually go into like real, hey, we have the concept. We know what we want to build. Now let's go do it for real so we can actually, actually deliver something that's reliable. So
Great, thank you.
yeah, thank you.
Jake, I can tell you from a manufacturing standpoint, when I was managing my employees on the plant floor, if I had some sort of piece of equipment or some sort of process in our truckloads of materials that say we're trying to be more sustainable on the plant floor, and we came up with a process, it was more about training and almost idiot proofing that you are unable to throw this out because it looks like this and it needs to be, or there's a rack system or a bucket that's far and away or right at the point of receiving it, and that it goes here, but it's you almost have to be very purposeful about the process and its use, as well as the training purposes. The training is obviously very important, but it's almost, you got to, for your case, you got to pretend you're that doctor and what that looks like.
Yeah.
What other questions do we have for DJ? Thank you for that question, Jake. That was great.
Yeah, it was great.
I have questions. No one else does.
Go ahead, Tim.
What kind of pushback, or did you get any pushback from, I guess I'll say the military, in terms of this thin slicing approach, or the concept roadmap?
Well, so the only involvement we had was we talked to a few personnel to understand how they would work through this. Data Anchor in this case, so the way these proposals work with, when they go through the proposal process with the military, it's you read the spec, you try to figure out what they're looking for, and then you propose a solution. And when you propose a solution, it's your final offer. Will it deliver what they're looking for? So we didn't get any pushback at all from the military because we really didn't have any involvement with them when it came to developing the product.
Okay.
This was all interaction with Data Anchor because they knew they wanted to get to the end goal. They had a certain set of requirements they had to meet for the proposal that they had to submit. They didn't, like the Wi-Fi version, they never submitted. It just got us to that end goal faster because we were able to iterate through it. So,
Thanks.
It's interesting, the question that Jake brought up about the sustainability portion and you not knowing whether or not the product was going to be reused or not. It really wasn't up to you to decide, nor was it part of the process that you were responsible for. So for you to think about and have that in your mind when dealing with your list of requirements and constraints, and then deciding what components go into the hardware and the software for that matter, that's got to be pretty difficult without knowing what that constraint or requirement is. I mean, it's almost like, do I make my product more powerful or do I make it cheaper? Right. And it's as long as you're meeting the customer requirements, it's almost like you have to make sure you're balanced.
Well, yeah, and I do know that a lot of the conversations we had with Data Anchor were around what is the cheapest we can build this, and not from a cheapness of the concept, not the POC, but it was long term, because I think their vision, at least from in the conversations that they had, was these are not $100 devices. They're hoping that if they can build these things for $3 or $4, and they throw every one of them in the trash when they're done, $3 or $4 is nothing, and so it may be a situation where they don't even have a process to reacquire them and put them back on the charging station. It literally may be a one and done. So that's something we didn't have the answer to. But I think as we go through that, we would obviously have to think through that. Obviously, we're not going to want to build these things at super high rates or a super high cost, because they are going to be something that they have to be rugged, and we're going to probably beat them up pretty good.
Awesome. Well, thank you so much for that, DJ. We've got time for another question or two if anyone wants to chime in.
Hey, I have one more if it's okay, Mike.
Go ahead,
This is
Jake.
Jake Miller.
Yeah, go ahead.
Hey, DJ, another question. Have you ever worked on a product that had an already manufactured other component as part of it? Say you had to develop what you're talking about now, but there was an already attached something that was pre-made. And do you have any recommendations for partnering with that type of supplier? I'm not talking about just like a Raspberry Pi that's part of your embedded stack, but
Yeah.
this is something like, I don't know, say you're doing a smart fishing pole and you bolt your thing on, but the fishing pole, you don't know how to manufacture. You're just going to buy off the shelf. Do you have any recommendations for pairing your technologies with some things that you may buy that's off the shelf? Because it's a lot easier many times to buy off the shelf.
Yeah. So are you asking about how do you marry the hardware together, or how do you marry this, like the software that will interact with that hardware?
Let's say that you have this off the shelf component. I'll use the fishing rod example because it's in my brain now, but and it has certain specs, and now you know that you need to attach in a certain way to this fishing rod. So your mechanical guys are going to design it in such a way that it's put together. But now you don't know the assurance that this is going to be in that exact shape, et cetera, is outside of your hands because you're buying off the shelf.
Yeah, well, to be fair, most of the work, we're more of a software company than we are a hardware or manufacturing company. So we don't, at least I don't have a lot of personal experience with getting to that level of actually integrating the components together. But I will, from a software standpoint, we run into that a lot where we have a component that we really know nothing about, or we have a component that we know how it's supposed to work. We know the interface that we talk to it through, whether it's a CAN interface or a Modbus interface or I2C, or pick whatever you want to pick. We know what kind of data we have to send it to get it to react the way we want it to, and then at some point down the road, the component gets switched out, whether a new version comes along or whether a new manufacturer delivers something, which obviously causes many challenges from a software standpoint. So the concept we use there, and I'm going to kind of come back around and hopefully maybe we'll apply this to the hardware side of it. But what we intend to do is, in all of our testing, we're writing tests on how this thing should behave. We actually abstract out the component and create a software stand-in for that component, so that the software that we're writing doesn't really know that the component is either there or it's not there. And so we're able to move forward, and as the component will change, we can change that software stand-in, but it gives us the speed of which we can do that.
Well, let's keep talking about your firmware examples. So a lot of times components switch out or manufacturers change, et cetera. You guys change chipsets quite often in your example you gave today.
Yeah.
It seems like the firmware would have to be rewritten because many times you're leveraging processes that are part of that embedded chipset, unless you guys purposely don't. Like, how do you balance that out, the amount of rework you have to do?
Yeah, in this case, we chose Python because it'll run on about every one of the devices that we had. And we also used sensors that had a interface, a programming interface between the sensor and the programming language. So we really never got to the firmware level. We were only talking through a software interface. So that made that part, in this case, that made that easy. In past experiences, we have had that situation where a new chipset will come along, or a new piece of hardware that we can't communicate with. That really comes back, I guess. I don't have a real detailed answer of how we would actually go and switch that out, but it does come back to the question that Mike asked earlier. It does affect the roadmap. So we have to have that conversation of, why are we switching out the chipset? Is it that much better? Could we stay with the old chipset and maybe not have as many features, but we might actually be able to release on time? Or is delaying the release valuable enough to get the new chipset in? Those kind of things. Getting down to the actual software communication of that. Obviously, if you change chipsets or you change the interface or the way you communicate, it's just going to affect timeline. There's no way of getting around it. It's just it's the joy of being in the software hardware world.
Thank you.
And then I got one last question I always like to ask about tools, because us early stage entrepreneurs often need a little hand holding. What types of tools do you utilize when either working on your product roadmap, when referencing your requirements and your constraints? Maybe there's something that you use to marry the two. What are you utilizing in this process?
So I'll give you the example of what I like, what's sitting in front of you. Most of what I'm using just from a presentation standpoint or a communication standpoint is, we're still small and probably will be fairly small for quite a long time. We're using all the Google tools, whatever the, the Gmail and Google Slides and Google Docs and all of that stuff, just because it's our world is now so remote, we're kind of forced into it, but we don't have an office. Everyone works from their own location. So that makes us really well connected in that case. We're using tools so the roadmap I built in a tool called Miro, which is an online sharing tool. It's really, really slick. It allows multiple people to be in there simultaneously. The nice part with Miro is it has history. So as you change things, you can roll forward and roll backward to see what you had last week, or why does it not look the same today as it did yesterday? And then you realize, somebody went and changed it and you didn't know about it, those kind of things. Like I said, we don't get into a lot of hardware stuff, so we're not doing a lot of management in that aspect of it. But from a software standpoint, we use whatever tools typically the client is interested in from a management standpoint. And there's Jira out there, there's Confluence, there's Trello. I mean, whatever people that we're working with tend to use what we tend to use there. And then as far as the code that we're writing, we use some form of code management, whether it's GitHub or GitLab or pick whatever flavor you want. But we do have, fairly stringent processes that we follow. They're not, when I say stringent, they're not overbearing or unwieldy, but they're just, we have the way we like to work. We write code, we check it in. We have tests that run against it. You have to get approval before you can check it in. Your peers have to agree with it, those kind of things. I'm sure there's probably, 50 more tools that I'm not even thinking about. From a startup standpoint, Slack, we use Slack a lot. Most of our IDEs that we write our code in are some form of a, IntelliJ or VS Code. We tend to like the open source free stuff only because we're, like the rest of you, we're small startup companies that don't like to spend their money on that kind of stuff. So, yeah, I mean, that's a good list.
Awesome. Thank you, DJ.
Yeah.
Well, I'm going to go ahead and hit stop on the recording.